let's take a look at an example that applies differentials. The radius of a ball bearing is measured to be 0.8 of an inch when it's new, and then later wears down to a radius of 0.78 of an inch. The volume of a sphere with radius r is v equals 4/3 pi r cubed. Part A. Use differentials to approximate the decrease in volume of the bearing. Differentials means that we are going to be using dV, the derivative of the volume. So we start with our volume formula, 4/3 pi r cubed, and find the derivative of it. dV, 4/3 pi, is just a constant multiple. We multiply by the derivative of r cubed, which is 3r squared, and then times the differential of r dr. Now the measurements are that the radius is 0.8 inches, and the radius wears down to 0.78 inch. So 0.8 minus 0.78 is a change in 0.02. So the change in the radius, or dr, is a negative change of 0.02 inches. Let's plug these values into dV to use the differential. dV equals, now I'm going to get rid of these 3's, common factor that divides out, so I don't have to worry about that. 4 pi times radius squared, radius is 0.8, 0.8 squared, dr, the change in r, negative 0.02. Compute that, and we get approximately negative 0.161 cubic inches. Cubic inches because this is a measurement of the change in volume. Now, word problems require words. So let's talk about how to answer this with words. It said use differentials to approximate the decrease in volume of the bearing. So we can say that the volume decreases by approximately because we used differentials to approximate the decrease in volume. So the volume decreases by approximately 0.161 cubic inches. Now, notice I didn't put the negative because the word decreases takes care of that, down by 0.161 cubic inches. B. Find the actual volume lost and compare the approximation to the actual volume lost. So the actual volume lost is going to be the change in volume, delta V, as opposed to dV, the differential of the volume, which is an approximation. So the change in volume, delta V, means the volume computed at the radius 0.78 inches minus the volume computed at the original radius 0.8. Plugging those into our volume formula, because we're calculating volumes, which with each of these is 4/3 pi radius 0.78 cubed minus 4/3 pi radius 0.8 cubed, and that gives us approximately negative 0.157 cubic inches. So this shows that the actual volume went down by 0.157 cubic inches. Let's write that in words like we wrote the approximation. The volume decreases. This time we don't have to say approximately because this is the actual volume loss, decreases by 0.157 cubic inches. Again, the word decreases takes care of that negative symbol, so we don't want to use a double negative and put a negative here as well. Now we want to compare the approximation to the actual volume lost. Remember, our approximation was a decrease by 0.161 cubic inches, and the actual decrease was 0.157 cubic inches. that approximation overestimated the actual change. It's over the actual change in volume. So we will say the approximation in change of the volume overestimates the actual change by, now how much? Well, from 0.161 to 0.157, that is 0.004. So the approximation and change of the volume overestimates the actual change by 0.004 cubic inches. Thanks for watching.